we get to see water in 3 different states, and that's odd. Hello and welcome to UiTM News. Today, we bring you an exclusive report on water consumption trends in wilayah Persekutuan Labuan based on a detailed study conducted by my group, which is Group 5. Labuan, a small territory in Malaysia, has experienced significant changes in water consumption over the past decade. This study focuses on annual water consumption in Labuan from 2013 to 2022. The data provided by the Department of Statistics Malaysia sheds light on how residential and industrial needs have evolved. Analyzing the data using Maple software, it reveals an interesting trend. The best fit quadratic curve, determined using the least squares method, illustrates the overall trajectory of water usage over the past decade.
Next, to understand these trends, we use a quadratic curve model through the least square method. This method minimizes the sum of the square differences between the observed data points and the predicted values by the model. It is particularly useful for fitting a curve to the data, ensuring the model best represents the overall trend. In this case, it helps to establish a quadratic model to reflect the nonlinear trend in water consumption over time. So, here is the manual calculation. Let me briefly explain the calculations performed in Maple. First, we load the data into Maple, defining the variables x and y. Since the quadratic equation is y equal a plus bx plus cx power 2, we define a1, which is a column of ones, and define the matrix A using the a1 and x data. To complete the matrix, we use a command to combine matrix A with y, which serves as our final matrix. Next, we apply the formula for normal system, which is A transpose AX equal to A transpose B. We start by calculating the transpose of A, then multiply it with matrix A to obtain A transpose A and compute its determinant. Similarly, we multiply transpose A with B using data Y to obtain A transpose B. We then combine A transpose A and A transpose B into a single matrix M. By applying the reduced row echelon form command to matrix M, we got this output. From the output, our least square are 16.2833, 0.1068, 0.0189. We can write this equation as y equal 16.2833 plus 0.1068x plus 0.0189x power 2. Finally, we use plot command to show the quadratic curve along with the data points to visualize the fit.
Next, I will explain the error vector calculation. This step evaluates the difference between actual and predicted values. The error vector is a critical diagnostic tool to measure how well the model fits the data. To calculate the error, we start by finding the error vector, which is the difference between the actual water consumption values and the predictions from the quadratic model. For instance, an error value like negative 0.0136 indicates a very small difference, while a larger error such as 1.2212 shows that the model's prediction is less accurate at that point. Here is the output if we use Maple. Next, for the magnitude, it is calculated as the total of all the errors combined into a single value, which is 4.0167 in this case. By looking at the magnitude, which is the square root of the sum of all the squared errors equal to 2.00416, we can assess the overall accuracy of the model. A smaller magnitude reflects better predictions, indicating that the model captures the water consumption trends in Labuan reasonably well overall. The magnitude of approximately 2 units in our results suggests moderate accuracy.
To summarize, the analysis of annual water consumption in Labuan from 2013 to 2022 reveals a nonlinear increasing trend captured by a quadratic model. While the model offers valuable insights into historical patterns and emerging trends, the magnitude of the error vector, approximately 2 units, suggests moderate accuracy, indicating that it may not fully account for the data's complexities. Nevertheless, understanding these trends through detailed analysis is crucial for sustainable growth in Labuan. Mathematical models like this provide a clear perspective on past challenges and future opportunities, emphasizing the need for refined approaches to ensure effective water resource management.